weaker in terms of electronegativity, and it is the number of electrons you lose to a stronger electronegative element. So in HCl, of course, chlorine wins over the electron and hydrogen loses, but doesn't happen the same in the case of P4. So what is the oxidation state and covalency? That question is answered. Next. What is the hybridization of nitrogen in ammonia? Once again, it is easier to say the hybridization is sp3 this or that. But how will you find for most of the molecules? I may suggest you a method which may not be useful for 100% of the molecules, but definitely I can say it is useful for more than 99%. So you just look here, it's a simple procedure. You can say it is a shortcut, there is not much of chemistry behind it, but nevertheless it's very useful. H is equal to V plus M minus C plus A by 2. Here V is number of valence electrons of the central atom, like nitrogen 2, 5, the number of valence electrons in nitrogen is 5. So V is 5 for nitrogen, and M is number of monovalent atoms. M is number of monovalent atoms. Means atoms which are forming just one bond. For example, in carbon dioxide, you can't strictly say oxygen is monovalent, is forming two bonds. So we ignore elements like oxygen. Means in CO2 we put M is equal to 0. Oxygen may be ignored, number of monovalent atoms. And what is that C? C is charge on the cation. Charge on the cation. Suppose you are asked to find out the hybridization of a cation, in which case you have to subtract the positive charge of the cation. Simply saying, if you have a plus, you subtract it. If you have a minus, you add it. Positive charge is subtracted, negative charge is added. These two terms C and A will come into play only in the case of a cation and an anion. And A is charge on the anion. Charge on the anion. So after doing all this, if you get H is equal to 2, the hybridization is said to be sp. If H is equal to 3, hybridization is said to be sp2. H is equal to 4, the hybridization will be sp3. 5, sp3d, like this. Some of you may find that this formula is not universal, that may not help us in all the molecules, but at least you should appreciate to the extent it is useful. It is applicable almost to 90-95% of molecules. So instead of mugging up the hybridization of large number of molecules, you just better focus on whatever at hand, whatever facility we have. This is the by far the best shortcut method to find out. Now let us apply this for NH3. Nitrogen, how many valence electrons it has? Belongs to fifth group, 5. And how many monovalent atoms it is bonded with the 3 hydrogens? 5 plus 3 by 2. 5 plus 3 by 2, 4. The hybridization is sp3. What is the statement? The hybridization of nitrogen in ammonia is sp3. Nitrogen is sp3 hybridized. And you can apply this to any number. CO2, carbon dioxide. It is 4. What is this 4? Valence electrons of carbon. We have to write valence electrons of the central atom. So 4 plus 0 by 2. Why am I putting a 0? Oxygens are ignored. You need not worry about oxygens. So we have found out the hybridization of ammonia. Look here. CO2 4 plus 0 by 2. 4 by 2, 2, which is sp. The hybridization is sp. Apply the same for whatever element you want, whatever compound. SO3. Of course, sulfur trioxide, a compound of the 6th group. We don't mind. The procedure is same for whether it is 5th group or 6th group. As you must have seen from the first question, we are never pertaining ourselves to a particular group. No doubt, we have to learn the compounds of fifth group, but when the procedure is the same for be it sixth group or fourth group or sixth group, we should not eliminate that fact, we should not overrule that fact, and wherever it is possible, you have to learn chemistry for that matter or any other subject with a cross reference, only by comparing by analogy. SO3, number of valence electrons. Sulfur, if you have any doubt, 16286. Why am I writing this? Why do you think I am writing this? Only to tell you sulfur has 6 valence electrons, 6 electrons in the outermost shell. So, sulfur 6 plus oxygens, which they are not divalent, they are not monovalent. Oxygens are not monovalent, they are divalent. Therefore, 6 plus 0 by 2, wherein you get just 3, the hybridization is sp2. So, what is the rule? When after you calculate all this, if you get 2 it is sp, if you get 3 it is sp2. I do agree that this formula may not be applicable in all the cases, but I can dare say this is good enough for our needs to learn chemistry in a very short time, as short time as possible. Perhaps in 2-3 hours you will learn so many procedures than what you otherwise do in 2-3 months time. That is the advantage you have to derive from whatever lectures you have at hand. Now, one more molecule, SF6. Sulfur belongs to 6th group, which indirectly tells you that sulfur has 6 valence electrons. 6 plus 6 by 2, once again 6, the hybridization is sp3d2. And when you apply the same formula for NH4 plus, nitrogen has 5 valence electrons, plus 4, 5 plus 4 minus 1 by 2. 5 plus 4 minus 1 by 2. So, what is this 5? The number of valence electrons on nitrogen, 4 monovalent atoms, and I told you when you have a positive charge, you subtract whatever the positive charge you have plus 1, make it minus 1. 5 plus 4 minus 1 by 2, 4, which is sp3. And let us apply the formula for an anion. What is the anion? Say SO4 2 minus. Sulfur, 6th group, 6 valence electrons, 4 oxygens, 0, 6 plus 0. I told you, whenever you have a negative charge, you add the negative charge. Minus 2 means make it plus 2 by 2. You get 4 as a result, and 4 means the hybridization is sp3. Okay? You already know the formula for cation, for anion, for our other molecules. How about XeO3? XeO3. 8 plus 0 by 2. 4. Once again sp3. So, a compound of 0 group, a compound of noble gas, but still the formula holds good. Formula is the one and the same. So, that is how we find the hybridization of molecules. Next question. Discuss some properties of ammonia. Discuss some properties of ammonia. It's a very interesting molecule. Look here. Ammonia NH3, nitrogen has 5 electrons in its outermost shell, like 2s2, 2px1, 2py1, 2pz1. Nitrogen, this is the electronic configuration of nitrogen in the outermost shell. So, nitrogen has a pair of electrons which are not actually used in bonding. Only these 3 electrons are used in bonding. Which 3 electrons? Only these 3 electrons are used in bonding. Actually, they are shared with hydrogen atoms. 1 electron each of hydrogen will participate in bonding. So, this is what you call ammonia. And these two electrons, sorry,